Hi, welcome to this course, ENSE 113 or the differential equation. For this video, we're gonna have some definitions and some terminologies regarding the differential equation or DE. Okay, so for the definition, when we have an equation that contains derivative, it is called the differential equation. So differential equation simply means an equation containing derivatives. Okay, so DE simply means an equation containing derivatives. So if we have equation, example, if we have this equation, derivative of y with respect to x plus y plus 1 is equal to 0, in this equation here is called differential equation because this equation contains this derivative, the derivative of y with respect to x. So another example, say we have y prime double prime plus y prime plus square root of 3 is equal to 0, and this equation here is also called differential equation because it contains these derivatives. Okay, so the differential equation can contain one or more derivatives. So say we have this third example, y squared plus x squared is equal to 1, and this equation here doesn't contain any derivative, so it is not DE. Okay, so say let's have another example. Say we have the x plus dx over dt is equal to t minus 4 squared. Then this equation here is also DE because it contains a derivative dx over dt. So once again, for the definition of our DE, it only means that differential equation is an equation containing derivatives. So this first example here contains derivative. Also, the second example contains derivative as well as the fourth example. But this third sample here has no derivative, so it is not DE. Okay, so after the definition of the DE, it can be classified also by type, order, linearity, or by its degree. So let's move on to some terminologies. So our DE can be classified in terms of we have one what we call type of DE. Type of DE. So we have two types of DE. The first one is called the ordinary differential equation, and we have the partial differential equation, or this one is called the ODE, and this one is called the PDE. Okay, so the classification by type: if an equation contains ordinary, if an equation if we have the DE, or the equation contains ordinary derivatives, then it is called ODE. Wherein if the equation contains partial derivatives, it is called partial differential equation. So let's have an example. So for example 1, we have dy over dx plus y is equal to 4. Okay, this equation here contains only ordinary derivatives. That's why it is under the type of ordinary differential equation, or ODE. Wherein, for example, here we have the partial derivative of y with respect to x plus y is equal to 4. Then, as you can see here, we have the partial derivatives. Our equation contains partial derivatives of y with respect to x. That's why it is under the type partial differential equation. Okay, so once again, if our equation contains ordinary derivatives, then it is called ordinary differential equation, or ODE. Wherein partial differential equation contains an equation contains the partial derivatives. Like here in our equation, we have the partial derivative of y with respect to x, and that is called the partial differential equation. So the type, or the type of DE here is PDE. Okay, another example. Say we have the 4 plus the second derivative of s with respect to r plus ds all over dr is equal to 0. Then here we have ordinary derivatives, That's why it is the type of differential equation is ODE. And for the second example of PDE, say we have the partial derivative of u with respect to partial derivative of y is equal to negative partial derivative of v with respect to partial derivative of x. So as you can see here, this equation contains partial derivatives. That's why it is under the type PDE. Okay, this equation here is partial differential equation. Okay, so that is the classification of DE by type. Once again, we have the ordinary differential equation and the partial differential equation. Ordinary means equation containing ordinary derivatives, and partial DE means equation containing partial derivatives.